Okay, similarity transformations. So we've been looking at similar shapes, and all similar means is same shape, different size. Now, technically they can be the same size, but if it's the same size, then that implies that that is not a reduction or an enlargement. They're just equal, which means the K value would be 1. In other words, the scale factor is 1 to 1. They're the exact same size. If the scale factor is greater than 1, then that means it got bigger in enlargement. If the scale factor is a fraction between 0 and 1, then that means it got smaller or it's a reduction. Okay, so we're going to look at these example exercises here. And it says determine whether the dilation from A to B is an enlargement or reduction. So it's always important to know what your beginning one is and what your end one is. So in this one, there's the beginning, there's the end, and that is an enlargement. It got bigger. Okay, so that part's easy. It's pretty easy to look at the picture and say, okay, it got bigger or smaller, so that's an enlargement. But how do you get the scale factor? Well, there's a couple of ways to do this. I think the easiest thing is to look for an easy side and count how long it is. So like this one, 1, 2, 3. So then we look at the corresponding side on the other one and we count it. 1, 2, 3, 4, 5, 6. So we went from 3 to 6. Now how do we do that? To get from 3 to 6, you have to multiply by 2. So there's your scale factor. So K here is 2. And remember, if it's an enlargement, it's got to be something bigger than 1. Okay, let's look at the next one. So here's A, and then here's B. So that one got smaller, so that's a reduction. Now we look and see how much smaller it got. So again, all I'm going to do is I'm going to count here. 1, 2, 3, 4, 5, 6. So that one's 6. This is 1, 2, 3. So to get from 6 to 3, you have to what? Divide by 2. 6 divided by 2 is 3, which means you're multiplying by 1/2. So when we say divide by 2, that means you're multiplying by a fraction. So in this case, your scale factor is 1/2. Remember, scale factors for reductions have to be fractions between 0 and 1. All right, let's do one more. Let's do number 4. So here's A. Oops, I use red here. Here's A, and here's B. So we got smaller, so again, it's a reduction. And let's count. Okay, so 1, 2, 3, 4. So that one's 4. This is 1, 2. So to get from 4 to 2, I have to divide by 2, which means I multiply by 1/2. So my scale factor is 1/2. So I'm going to pause the video for a second. I want you to try number 3 on your own, and then we are going to check it. So take a minute, pause the video, try to do number 3 on your own, and check it. Okay, so what did we get? We got a reduction. Now, the scale factor here is a little bit harder because if you counted 1, 2, 3, 4, 5, and then 1, 2, 3, 4. So to get from 5 to 4, because it's not an exact number, what we have to do there is we have to multiply by a fraction. So to get rid of the 5, 5 has to be on the bottom. To end up with a 4, 4 has to be on the top. So there's our fraction. So our scale factor is 4/5. Okay? Or here's another way you can think about it. You take the new and divide by the old. So the new number was 4, the old number was 5. So let's go back and look at the others and see if that works. What was the new? 6. What was the old? 3. What's 6 divided by 3? If you simplify that, you get 2, which is what the scale factor was. Let's do one more. Here's the new, 3. Here's the old, 6. What's 3 divided by 6? If you reduce that, you get 1/2, which is what we got for the scale factor. So to get the scale factor, I'm going to write this down. Remember, always do new divided by old. New divided by old. All right, next page. So here we're doing the same thing, but now we don't actually have the picture drawn for us. So what you want to do here is you want to graph it. So you want to get some graph paper and use graph paper to put this on here. So I'm going to do one of these, and that should be okay. I'm going to do number 2, and the reason I want to do number 2 is because it actually has some decimals in it. But that's really not going to affect us a ton. So again, use your dry erase boards with graphing lines on it. But I'm going to draw a graph here. So let's draw the original figure. Okay, so the original figure is this one. Okay, so we can call that the old. So P is at -4, 1. Oops. Q is at -2, 4. And then R is at 0, 1. Alright, so there's our triangle. Now let's do the new. Okay, so the new here, and I'm actually going to use red for this. So the new is at 1 and -1.5. So there's W. And then 2, 0. So there's X. And then 3 and -1.5. Okay. So that's Y, sorry. So we can see that it is a reduction. So it's gotten smaller. And that's really all you have to do. Now, I could get the scale factor, and again, to get the scale factor, I'm going to do like I did before. Since these are straight across from each other, that's 1, 2, 3, 4. That's a distance of 4. Okay, and this is 1, 2. So if we go back for our scale factor, remember scale factor was new over old. So the new here was 2, the old was 4. If you reduce that or simplify it, then you get a scale factor of 1/2, which matches what we just said, a reduction. It got smaller. So similarity transformations using dilation.